how did we, if you recollect, we had gotten the equations. We had gotten the equations for sigma xx and sigma yy. Sigma xx equal to sigma xx equal to 2 mu del u by del x minus 2 by 3 del u by del y plus del v by del y. This is what we had gotten. That we have to derive now. How did we get this? So I had said that we will be deriving a little later on. Now is the time we will take it up. There are a lot of equations. I don't intend to write all the equations. Let us see how do we do that. So what are we trying to do here is relation between stress and strain terms. Stress and strain terms. So there are several assumptions. Which we shall read over. Okay, so back to slides. So if we get back to slides, so we get that these are the listed out assumptions. So what we will do is we will assume in elasticity, we assume that stress and strain obey Hooke's law. That means stress may be expressed as a linear function of strain rates. This is one of the major assumptions which we are going to do. And relation between stress and rate of strain components must be invariant of either rotation of the coordinates or mirror reflection. We are going to use both of them during our derivation. And if I put all the stresses as 0, I should be getting the hydrostatic pressure alone. When all the gradients of velocities are 0, the stresses would reduce to hydrostatic pressure. So these are the three assumptions. Let me state. Stress is proportional to rate of strains, and my relation between stress and rate of strains are invariant with the coordinate transformation, that is either rotation or reflection, mirror reflection, and the stress components will reduce to hydrostatic pressure when all the gradients of velocities are 0. So this is what we get. So now, so that means what? Sigma xx, I will just write once, sigma xx A1 epsilon xx plus B1 epsilon yy plus C1 gamma xy plus D1, and sigma yy is equal to A2 epsilon xx plus B2 epsilon yy plus C2 gamma xy plus D2. Sigma xy is equal to A3 epsilon xx plus B3 epsilon yy plus C3 gamma xy plus D3. This is equation 1. Whole of this, we are calling this as equation 1. Okay. Now, this has been done with x and y as my coordinate system. Let us say I rotate this coordinate system, that is to x prime and y prime, with theta being the angle between the old and the new coordinate systems. So now what will happen? We have said that if you get back to slides, you will say that the assumption B says that stress and strain rate relation remains unaltered with respect to the new coordinate system. Our new coordinate system is x prime y prime. So even with x prime y prime, my constant should remain same, that is sigma x prime equal to A1 epsilon x prime plus B1 epsilon y prime plus C1 gamma x prime y prime plus D1, and sigma y prime equal to A2 epsilon x prime plus B2 epsilon y prime plus C2 gamma x prime y prime plus D2. Now sigma x prime y prime equal to A3 epsilon x prime plus B3 epsilon y prime plus C3 gamma x prime y prime plus d3. So that means what did we say? These are, let us call this as equation 2. So even if after I rotating, my constants a1, b1, c1, d1 didn't change. So this is what we need to notice. Now if we get back to slides again, here we have derived these relations in strength of materials. We would have studied this. That derivation I am not doing, because that I can take it from here. That is, I write sigma x prime is equal to sigma xx plus sigma yy by 2 plus sigma xx minus sigma yy by 2 cos 2 theta plus sigma xy sin 2 theta, and again sigma y prime is equal to sigma xx plus sigma yy by 2 minus of sigma xx minus sigma yy by 2 cos 2 theta minus of sigma xy sin 2 theta. So then you have sigma x prime y prime equal to minus of sigma xx minus sigma yy by 2 sin 2 theta plus sigma xy cos 2 theta. That is how I can get back my xxyy from x prime y prime. So what this, we shall call this as equation 3. Now what we will do is, we will substitute 1 in 3. Getting back to slides, if you just see here, this was 1 and this is what we got as 3. So I will substitute equation 1 in 3. That is, for sigma xx I will substitute this, sigma yy I will substitute this, and sigma xy I will substitute this equation. That is, if I have to retell you the same thing, what I am telling is that I am having 1 and 3 here, 1 and 3. So what I will do is, I will substitute for sigma xx here, in this I will substitute from this term, and sigma yy this term, and sigma xy whole of this. When I substitute that, getting back to slides again, if you just see that, you will get this a1 for sigma xy. If you substitute a1 epsilon xx, d1 epsilon yy, c1 gamma xy plus d1, whole of this I have substituted, and sigma yy is a2 epsilon xx plus b2 epsilon yy, c2 gamma xy plus d2, so on and so forth. Again I will substitute xx, yy, sigma xy and group them. When I group them, I get, you see, a1 by 2 is one term, 1, that is a1 by 2 into 1 plus a1 by 2 into cos 2 theta. So I have a1 by 2 into 1 plus cos 2 theta. Similarly, a2 by 2 into 1 minus cos 2 theta, a3 sin 2 theta, and similarly I can write for epsilon yy b1 by 2 into 1 plus cos 2 theta, b2 by 2 1 minus cos 2 theta plus b3 sin 2 theta, and gamma xy c1 by 2 into 1 plus cos 2 theta, c2 by 2 1 minus cos 2 theta plus c3 sin 2 theta, because all these three are same, so they look similar, but this will be different. So d1 by 2 plus d2 by 2, that is d1 by 2 into 1 plus, here d1 by 2 I have and cos 2 theta I have, so 1 plus cos 2 theta, d2 by 2 again 1 minus cos 2 theta, because here I have minus d2, 1 minus cos 2 theta, and d3 sin 2 theta. So this is what I call that as equation 4. So just to recollect, we just substituted sigma xx, sigma yy, sigma xy in these equations and got this group terms. Now we know that similar like sigma xx, for strain also, we know that epsilon x prime is equal to epsilon xx plus epsilon yy by 2, epsilon yy by 2 plus epsilon xx minus epsilon yy by 2 cos 2 theta plus gamma xy by 2 sin 2 theta. and epsilon y prime is equal to epsilon xx plus epsilon yy by 2 minus of epsilon xx minus epsilon yy by 2 cos 2 theta minus gamma of xy by 2 sin 2 theta. Gamma of x prime y prime by 2 is equal to minus of epsilon xx minus epsilon yy by 2 sin 2 theta plus gamma xy by 2 cos 2 theta. Let's call whole of this equation as 5. What are we going to do now is back to slides. We will substitute 5 in 2. 5 we had sigma xx, epsilon yy prime, gamma xy, x prime, y prime. Now I have relations for epsilon x prime, epsilon y prime, gamma xy, x prime, y prime by 2. So I would substitute for epsilon x prime here, epsilon y prime here, gamma x prime, y prime, whole of this here. When I do that and group it, so what is that I get is epsilon xx into a1 by 2 into 1 plus a1 by 2 into 1 plus cos 2 theta, b1 by 2 into 1 minus cos 2 theta and minus c1 into sin 2 theta. Similarly, plus sigma epsilon yy into a1 by 2 into 1 minus cos 2 theta plus b1 by 2 into 1 plus cos 2 theta plus c1 sin 2 theta and plus gamma xy a1 by 2 sin 2 theta minus b1 by 2 sin 2 theta plus c1 cos 2 theta plus d1. So I get equation 6. Now you see I am putting 4 and 6. 4 I had gotten by substituting sigma xx. 6 I have gotten epsilon, substituting epsilon x prime. Both are same, left hand side is same. So right hand side coefficients I can compare. Right hand side coefficients if I compare, what is that I am going to get? I get it as, if I compare epsilon xx coefficients, I get a1 same. So b1 equal to a2, and a3 equal to minus c1, Similarly, you see here b1 epsilon yy, if you compare this, b1 equal to b1, there is nothing here. So b2 equal to a1, that's what I have written here, a1 equal to b2, b2 equal to a1. Now gamma xy, if we take c1 plus c2, c1 minus c2, because this is cos 2 theta coefficients, if I take c1 minus c2 by 2 is equal to c1, that is the coefficient of cos 2 theta. So c1 equal to c1 minus c2 by 2, so you get 2c1 equal to c1 minus c2. If you pull this c1 this side, you get c1 equal to minus c2. Now you see the last coefficient, that is a1 minus b1 equal to c3. How do I get that? a1 gamma xy, by comparing gamma xy, a1 minus b1 by 2 sin 2 theta coefficients, if I take a1 minus b1 by 2 is equal to c3. That is what is this. Now comparing the last coefficient, which is coefficients only, that is d1 plus d2 by 2 equal to d1. So that is d1 plus d2 by 2 is equal to d1. So you get 2d1 equal to d1 plus d2. So you get d1 equal to d2. This is plus d2. This is a typo. Please correct it. So 2d1 equal to d1 plus d2. So you get d1 equal to d2. And d3 nothing is there. So d3 is equal to 0. If I summarize, I get a1 equal to b2 equal to a, b1 equal to a2 equal to b, c1 equal to minus a3 equal to b3 equal to minus c2 equal to c, c3 equal to a minus b by 2, d1 equal to d2 equal to d, and d3 equal to 0. Now, this is what I did. So now what will I do is, I am substituting sigma xx prime a1 b1. I am substituting these coefficients here. So a1 becomes a, b1 becomes b, c1 becomes c, and a2 is b, b2 is a, c2 is minus c, d2 is d, and a3 b3, a3 is minus c, and b3 is c. That's what I have substituted and taken common, and c3 is a minus b by 2 gamma xy. Now what am I going to do is, I had rotated so far. Now I will take mirror coordinates. Mirror coordinates means what am I doing is here I just take, I had x and y. So now I will take x and x1 and y1. That means x1 equal to minus x, y1 equal to y. That means u1 equal to minus u, v1 equal to v. So getting back to slides again. So what will happen? Epsilon x1 is equal to del u by del x1. U is minus, u1 is minus u, x1 is minus x. So minus minus gets cancelled. So you get plus del u by del x only. Similarly, del v1 by del y1 is del v by del y. So gamma x1 y1 equal to del v1 by del x1 plus del u1 by del y1. Here you have x1 as minus and y1 u1 as minus. So you get minus del v by del x plus del u by del x del y, that is minus gamma xy. So epsilon x1 equal to epsilon xx, epsilon y1 equal to epsilon yy, sigma x1 equal to sigma xx, sigma y1 equal to sigma yy, sigma x1 y1 equal to minus sigma xx. So if I substitute this for sigma x1, so I get a epsilon x1, b epsilon y1. Notice this has become minus because gamma is minus. So this is again same, b plus a same, but this minus has become plus because gamma x1 y1 equal to minus gamma xy. So here again minus sigma xy equal to minus sigma x1 y1. So if I substitute, if I multiply throughout by minus, so I get plus c epsilon x1 minus epsilon y1. Here gamma xy is equal to minus x1 gamma x1 y1. So I get here minus of minus as plus. So a minus b by 2 gamma x1 y1. So now you compare. So what is that it says? If I compare equation 7 and 10, we said that according to assumption B, whether I rotate or I take a mirror reflection, the coefficients have to be same. That is, it should be independent. But you see here, if you just see here, plus c minus c plus c. So it is not possible. Here minus c plus c. So it will be same only when these two equations 7 and 10 will be same only when c is equal to 0. So that is one thing for while mirroring. If sigma x1 sigma xx has to have same coefficient, your c has to be 0. So getting back to slides again, so you get that c equal to 0. If you substitute, you can see here it is just the same. So you get sigma xy equal to a minus b by 2 into gamma xy. So now if you substitute, now what does the other assumption say? Stress reduces to pressure when all gradients are 0. So all gradients, if I make 0, that is epsilon xx, epsilon yy, gamma xy, this is epsilon xx, epsilon yy. If I make 0, I get d equal to minus p. And I know that shear stress is proportional to rate of shear strain. So I have sigma xy proportional to gamma xy, that is sigma xy equal to mu gamma xy, that is sigma xy equal to, I have another equation, a minus b by 2 into gamma xy. That means a minus b by 2 is equal to mu, comparing these two equations. Here one thing I am telling without proof is by Stokes hypothesis. If I get time during the course, I will teach you this, but for now I will have to state directly. By Stokes hypothesis, b is equal to minus 2 by 3 mu. I am taking back to slides. B equal to minus 2 by 3 mu. If I take, I get a equal to 2 mu minus 2 by 3 mu. So next is, if I substitute this d as minus p, b as minus 2 by 3 mu, a as 2 mu minus 2 by 3 mu, 2 by 3 mu, I get sigma xx equal to 2 mu minus 2 by 3 mu del u by del x plus minus 2 by 3 mu for b del v by del y minus p. So if I do the algebra, that is I get 2 mu del u by del x minus of 2 by 3 mu del u by del x plus del v by del y minus p. So similarly you can get sigma yy also as same, Sigma xy also as mu del u by del y plus del v by del x. So this was what we derived for two-dimensional flow. Now if I extend it for three-dimensional flow, it's going to remain same. 2 mu del u by del x minus 2 by 3. This is del dot v, that is del u by del x plus del v by del y, del u by del w by del z, and you can derive del sigma zz also this way. So you get sigma xy equal to mu of del u by del y plus del v by del x. So the summary of this is that, you see, we invoked only three assumptions. That is, stress is expressed as a linear function of rate of strains, that is a1 epsilon xx, b1 epsilon yy, c1 gamma xy plus d1 equal to sigma xx. This comes from linearity assumption, and it is invariant. Stress components and strain components relations are invariant with coordinate transformation, either rotation or mirror reflection, and stress is reduced to hydrostatic pressure when all gradients of velocities are zero. So this brings us to the basic thing which we took in the Navier-Stokes equation, that these stresses are related to strain rates, and this derivation, I know I have gone fast, but I would request you to go back and redo this derivation yourself using pen and paper, although I have done it with slides. I would request you to do it with pen and paper and get yourself convinced that everything what is being done here is good. Thank you.